All right, so we defined coordinate maps, we've defined the coordinate vectors, and really what we've learned is that for any basis for a vector space V, we end up with two functions. One going from V to R and one going from Rn to V. These map would identify any n-dimensional vector space with Rn. So you think, all right, so we don't need to study all of them. They're all exactly like Rn. There's a bit more because the identification depends on a choice of basis. So once you fix a basis, then the two are the same. But choosing a basis is a bit arbitrary in general, and so the identification is not natural. Right? The questions that we have left to answer, and that we'll answer in chapter 2, is what kind of map would these be? So that they respect in some way the vector space structure. So what we'll see is that they're linear maps, which we'll define in the next section. And then how would these maps relate for different bases? What if I take two bases, B1 and B2 for V? I get two different coordinate vector for it, for the same V. And so what is the relationship between them? Ideally, we would be able to determine the dash map in the following diagram. So I have V, it goes to Rn, and it goes to Rn. It goes to Rn in two different ways. And so we want to bridge this gap and see what kind of relationship we get between Rn and Rn. All right, so in the next chapter, we will be studying linear maps between vector space. Once we have studied these maps, we will come to discuss these change of basis function right here. And those are important.